this video, we're going to look at a Leetcode problem called top k frequent elements. So given an integer array and an integer k, return the k most frequent elements, and the answer can be in any order. So you can see here we have an example of this, right? So this integer array, and then we want to return the top two frequent elements. So in this case, we going to have 1 and 2, right? In this case, you can see 1 appears 3 times, 2 appear 2 times, and 3 appear 1 time. So therefore, we're just returning 1 and 2, or in this case, we can return 2 and 1, right? Because those two are the top two frequent elements. And then you can see here, k is only 1, and then in this case, the top one element is just 1, right? So the constraints is that it is guaranteed that the answer is unique, and you can see here the array is guaranteed to be non-empty. So the goal for this question is we really want to solve this problem better than, right? Better than n log n time complexity, right? Where n is the number of the size of the array. So in this case, to solve this problem using n log n, we know how to do that, right? We can basically first create this map, right? This table. In this case, the key, right, will be the basically each and every single element, right? So each and every single element, and then the value is basically the number of times this element appears. So in this case, 1 appear 3 times, 2 appear 2 times, and 3 appear 1 time, right? And then what we're going to do is that we're going to basically sort these arrays, right? Sort the keys, right, based on the value, right? So in this case, we could have like an array like 1, 2. These are the unique elements, and then we're going to sort the array based on their number of times, their frequency, right? Their number of frequency. So in this case, 1 appear 3 times, so 1 appear first, right? 2 appear 2 times, so 2 appear the second, and then 3 appear 1 time, so 3 appear third, right? But worst case scenario, we could have each and every single element appear only 1 time, so the time complexity will be just n log n, right? So n log n. So in this case, what we can do even better is we can be able to use a heap, right? So in this case, a heap, we can basically keep a size of k. So let's say k is 2, right? In this case, we only have 2 elements in our heap. So what we're going to do is we're going to have a min heap, right? And then what we're going to do is we're going to compare the top element with the next element that we're going to add, right? So for example, in our code, basically what's going to happen is the same thing. We're just going to keep track of each and every single element's appearance, right? A frequency in a table. So the key is basically the element itself, and then the value is basically going to be the number of times or the frequency of that element. And then what we're going to do is we're going to define a min heap, right? So we're going to define a min heap, and then we're going to sort based on their frequency. So we keep adding those elements that we have in our key onto our min heap. Once the size of the heap exceed the k, then we can basically take the top element out of the heap, right? And at the end, we're basically just going to add the top k frequent elements, or basically all the elements that we have in our heap, onto the result array. And then we're just going to return that, right? But this will give us a time complexity of big O of n log k, right? So n log k. The reason why is n log k is because here you can see the size of the heap, right? In this case, for insertion and deletion, it's basically going to be log k. So therefore, we're going to iterate each and every single elements that we have in our keys, right? And then we're going to perform a log k time complexity for insertion and deletion. So therefore, the time complexity overall of this algorithm is going to be n log k. So how can we be able to even further improve the solution? How can we be able to improve the time complexity? Well, so to improve the time complexity, what we can do is we can use something called bucket sort. So bucket sort, basically what we're going to do is that we're going to do the same thing, right? First, we're going to keep track of their number of times it appears, right? So in this case, same thing. So 1 appears 3 times, 2 appears 2 times, 3 appear 1 time, right? So what we're going to do is that we're going to basically use bucket sort, and we're trying to improve the time complexity down to a linear by utilizing another table, right? So once we know how many times each and every single element, basically each and every single element's frequency, what we're going to do then is we're going to convert this table into another table, and this another table has a key that is the frequency, right? So the key is basically now the frequency. And then the value, right? So in this case, the value, let's draw it this way. So key is basically the frequency. And then the value is basically the list of elements, right? So in this case, what we're going to do is that we know that 1 appear 3 times. So in this case, what we're gonna do is we're gonna have, so basically this is the list of elements, right? List of elements. Okay, so in this case, we're gonna have like 1 here, right? And then 2, so for frequency 2, in this case, we're gonna have only 2. For frequency 1, we're gonna only have 1 element, right? In this case, basically 3. And let's say we also have like another element, in this case 4, right? So what we're gonna do is we're just gonna append it onto this list, right? Right, so it's like this. So let's say in this case k is 2, so what we're gonna do is we know that the maximum frequency is gonna be the size of the array, right? So 1, 2, 3, 4, 5, 6, 7, right? So in this case, what we're gonna do is that we're gonna go from 7, right? Iterate from 7, integer value 7, to, in this case, 1, right? And then what we're going to do is that we're going to check to see if we have that frequency, we have that value in the table. In this case, let's say 7 does not have it in our table, and all the way going down to 3, so 3 does have it in our table, right? So what we're going to do is we're going to add that element onto our list, onto our result list. So we have 1, and then what we're going to do is the next element is 2, right? So in this case 2, we actually have a value which is 2, so we add 2 onto it. And then once we have a size of 2, right, size of k, then we can basically return this array, right? So this is basically how we're going to utilize this bucket sort. We're basically using 2 tables. One table is one bucket is keep track of all the elements appearance, right, all the elements frequency, and then we use that bucket, use that table to create another table that the key is going to be the number of frequency, and then the value is going to be the list of elements that has the same frequency. So you can see here in our code, we're doing something similar, right? First, we're going to basically save each and every single element's frequency in a table, right? This is our first bucket. Now the second bucket is we basically store each element's frequency as the key. So you can see here, for each and every single elements, right? For each and every single key in bucket 1, we're just going to get their frequency, and then we check to see if bucket 2 has that frequency. If it doesn't, we're going to create a list, and then we're going to add this current element onto this current frequency, right? So then what we're going to do is that we're going to get the top k elements, right? What we're going to do is we're going to create a result array with size of k, and then we're going to go from n, right, to basically 1, right? We're not going to go down to 0 because we want to make sure, right, for if there is an element, then their minimum frequency is just 1, right? So in this case, we check to see if bucket 2 contains that element. In this case, if it does, then we're just going to get the list, and then we iterate the list, right? Remember, we want to iterate basically k number of times, right? We basically want to get top k elements, not all the elements. So if k in this case is equal to 0, right, you can see that because the order doesn't matter. So in this case, result k minus minus, right? We basically get the last index is equal to integer, right? And then if k is equal to 0, then we just return the result. And because in this case we want to return something at the end, right? Let's just say that if we have a situation where in this case k is actually bigger than the number of elements that we have in our array, then at the end we can just return the list, right? So you can see that this will basically help to bring the time complexity down to a big O of n, where n is the number of elements that we have in the array. So there you have it, and thank you for watching.